There are four principles of soil health. Number one, minimize soil disturbance, which is minimizing tillage. Secondly, maximize biodiversity. Diversity includes crop rotation, cover crops, and livestock. Next, maximize living roots. This is planting annual cover crops. This also includes perennial crops such as alfalfa. And the fourth principle of soil health is to maximize field cover or keep the soil covered. This is accomplished with residue from reduced tillage and planting cover crops. As soil health improves, there are some indicators of soil health that will demonstrate this. Listed in this slide is our website at the Soil Health Institute for our North American project to evaluate health managements, where we have more information about the indicators of soil health. We have one group of indicators classified as Tier 1 soil health indicators. I will not go through all of them. You can review them further at our website, but just to name a few, one of the indicators is soil pH. Another is soil carbon, soil texture, and then bulk density, aggregate stability are just some that are listed here. These are measures that will change as soil health improves. Another group are the Tier 2 soil health indicators, and these can be reviewed in more detail at our website. Now, as soil health improves and the indicators are signify this, from the farmers that we have interviewed, also other factors are changing, such as weed suppression increases, sometimes beneficial insects increase, and also crops develop disease resistance. So when all these come together, soil health increases potentially affect crop yield and production inputs. So in this case, farm income is a measurable benefit of soil health. This chart gives a picture of where we are right now in the U.S. of farmers adopting soil health practices. These data are from the 2017 Census of Agriculture by the National Agricultural Statistics Service. We see that in the U.S., 37% of planted acreage are with no till. 35% are with reduced till. So combined, these are 72% of a conservation tillage practice. But then for cover crops, we see that only 5% of the acreage is planted with cover crops. Our objective is to provide farmers with the economics information they need so they can make a proper decision about adopting soil health management systems. Our approach is to use farmer surveys to collect economic information. The survey participants are selected farmers who have long-term experience practicing soil health management systems. The field production data compares initial conventional practices and adopted soil health management practices. Our analytical approach is partial budget analysis, which compares costs and benefits with and without soil health management systems. More information, more detailed information is available at our website listed in this slide. Our analysis includes only factors that differ between conventional and soil health management system practices. We look at the economic analysis of field activities, inputs, and production. So we calculate the benefits of adopting soil health management practice and also the cost. And the difference is the change in net farm income. In the analysis, we look at crop prices received, fertilizer prices, and fuel prices that are regional long-term averages. They're not current or farm prices at the time of data collection. And also incentive payments such as from USDA are omitted. These payments are often available only for limited acreage or for limited duration. So far at the Soil Health Institute, we have conducted 4 studies with farmer survey data. Our largest one was 100 farms that we did with Cargill in the major U.S. corn and soybean production region. These are the 9 states that were included where we interviewed the 100 farmers. Our other project was with the National Resource Conservation Service. This was 25 farms that we have completed, plus 5 more farms that we are yet to complete. This is an ongoing study in collaboration with the National Association of Conservation Districts. This study includes crops from different regions of the U.S., and these crops are listed in this bullet. Our other project is Healthy Soils for Sustainable Cotton. And in this, we interviewed 5 farmers in the Cotton Belt, producing upland cotton in the rotation crop in these 5 states. And then our other project was with the National Association of Conservation Districts. And in this one, we interviewed 3 farms in Pennsylvania and New Jersey. And the crops included were corn, soybean, and wheat. So a summary of the 4 studies for farmers who adopted soil health management system is that all of them increased average net farm income by adopting soil health practices. For the Cargill study, the average for corn and soybean was $48 per acre. For the NRCS study, it's $86 per acre for the 25 farms that we have completed thus far. For the Healthy Soils for Sustainable Cotton study, the average increase in net farm income was $101 per acre. And so for our final study, the 3 farms, the average increase was $32 per acre. After giving these aggregate results for these studies, we want to come in now and take a look at some selected individual farms to get an idea of what it looks like when farmers adopt the soil health management system. Our first one that we'll look at was the farm of 310 acres in New Jersey. They've been practicing no-till for 15 years. The original practice was conventional tillage. We see that for corn, the field activities and inputs that are omitted by discontinuing conventional tillage, field activity of chisel plow, then disc. And this farm in conventional tillage, they had to hire hand labor to go through and hand pick rocks, and this was $10 per acre. Then after this, there was another disc field trip that has now been eliminated. And then the crop is planted. After foregoing the field activities for conventional tillage, the only activity that had to be added was spray herbicide. And this is to control weeds in place of what was done for tillage. Similarly, for soybean, it's almost the same, 2 disc trips, hand picking rocks again, and then a field trip for a packer roller were eliminated from conventional tillage. Again, the only activity that was added was spraying of the herbicide. And these are the results for this one farm from going from conventional till to no-till. We see that the reduced expenses total $37.28. Additional expenses were $24.15. So the reduced expenses are greater than the additional expenses. So right off, we have an increase in net farm income just by the reduction in expenses. But also this farm stated that due to adopting this practice, the yield for corn on average had increased 2 bushels per acre. So this is an increased revenue of $9 per acre. So if you sum up all the benefits, reduced expenses, and additional revenue, the total benefits are $46.28. The total cost are the $24.15. So the difference is a change in net farm income of $22.13. Results are very similar for soybean. Reduced expenses are greater than additional expenses. For soybean, there was no change in yield, no increase in yield due to adopting the soil health management system. So the total benefits are $32.77 with the additional cost $23.25. So for soybean, the change in net farm income was an increase of $9.52. The second farm we want to look at is in Delaware. This is a farm that went from conventional till, and we collected data for no-till and cover crops. This farm is 2,500 acres and has been practicing no-till and cover crops for 15 years. We have corn and soybean again. We see that initially in conventional tillage and adopting no-till with cover crops, the farm was able to eliminate several field trips, 2 with a disc, a chisel plow, field cultivator, and also eliminate a vertical tillage, and then come in and plant the corn. In the conventional practice, the farm was having to control weeds with a herbicide Balance Flex. Also, since adopting the soil health management system, the farmer has been able to decrease 50 units of N. This is because he's using a cover crop that's $20 per acre, and the mix is a winter cereal rye, and then also a hairy vetch. He plants the cover crops with a narrow row planter, and then he comes in and plants the corn green. The cover crop is still standing. Then after he plants it, he terminates it with a 2,4-D herbicide. For soybean, the farm was able to eliminate 3 field trips for tillage, then adding cover crops with a seed that's $14 per acre. And for soybean, just one seed was used, and it's the winter cereal rye, and it was broadcast. And then he also came in and planted green with a no-till planter again. And in this case, the herbicide that was application that was used for termination was also the herbicide application that would have been made in conventional tillage. So in partial budget analysis, they cancel out, and we don't have to account for that. Results for this farm in Delaware: reduced expenses totaled $98.90. Additional expenses, $46.81. The farmer said there was no increase or decrease in yield due to adopting no-till and cover crops. So the reduced expenses and the additional expenses are the total benefits and the total cost, and the difference change in net farm income is $52.09. For soybeans, the sum of reduced expenses is $33.93. Additional expenses, $28.54. Again, no change in yield, no increase in yield to adopting no-till and cover crops. And if you take the reduced expenses and additional expenses with the difference, it's a $5.39 increase in net farm income. So now we want to consider the transition as a farm goes from conventional tillage and adopts a soil health management system. The complete transition in one case is conventional till, and then go to no-till or reduced till. But also a second alternative that we have observed in these first 2 examples, start with conventional till, no-till, or reduced till, and cover crops. We see that, remembering our data from the initial slide about soil health practices adopted, right now in the US, we have 37% of the acreage with no-till, 35% reduced tills, for a total of 72%. But cover crops were only 5%. This is an indicator that when farmers do adopt cover crops, they do it in stages. They go from conventional till, then go to no-till, and then they add cover crops as a later stage. As farmers are in conventional till and reduced tillage and go to no-till and reduced tillage, immediately they have reduced expenses. They are eliminating tillage practices and potentially adding a chemical application to make up for this in weed control, but this is generally less expensive than the tillage practices that are eliminated. So net farm income generally is going to increase when you go from conventional till to no-till. Now, when you're already in no-till and reduced till and you add cover crops, you're going to have immediate increased expenses. Purchase cover crop seed, then plant the cover crop seed and terminate the cover crops. So the question is, what is the long-term benefit of adding cover crops to no-till? The question is, do benefits compensate for increased expenses? In our previous presentation of January 18th, we used aggregate results from our Cargill analysis to demonstrate, yes, that the long-term benefits are greater than the cost when cover crops are added. So we have three different circumstances potentially. The farm is analyzed from conventional tillage to no-till or reduced till, conventional tillage, and then our second example, the soil health management system had data collected, no-till, reduced till, and cover crops. But now the third example would be, consider what if a farm was already in no-till or reduced till and wanted to add cover crops. Recall from our previous slide that this is going to be an immediate increase in expense by purchasing the cover crop seed, planting the cover crop, and then terminating the cover crop. Our next example is a farm that was initially, as we collected the data, no-till, and then cover crops were added to no-till. This is 800 acres in Minnesota. The farmer's been practicing no-till for 20 years, and then for 10 years, it has added cover crops. So the analysis that we're doing, initially the farm is in no-till, and then it's going to add cover crops. So initial is no-till, and the adopted, in this case, is going to be no-till with cover crops. As the farm adopted cover crops, it was able to eliminate an application of atrazine, a herbicide. Over 10 years, the farm has been able to eliminate or reduce 50 units of nitrogen, also reduce 30 pounds of phosphorus and 30 pounds of potassium. And also in this farm, they were grazing cover crops. And this calculates the value of the graze, and if the farm had to purchase the forage, the farmer valued this at $25 per acre. So for corn, the cover crop seed cost was $20 per acre, and the mix was winter, cereal, rye, rapeseed, radishes, and turnips. And the cover crops were custom planted at $11 per acre. For soybean, after adoption of planting cover crops, the farm was able to eliminate a herbicide or prowl, a spray of Liberty herbicide, and also reduce by 30 pounds phosphorus and 30 pounds potassium. Again, for soybeans, the cover crops that were planted before soybeans were also grazed. Again, the cover crop seed cost is $20 per acre. It was the same cover crop seed mix planted for $11 per acre. So these are the results in this case. Total reduced expenses, $55.94. Additional expenses, $40.74. The farm said that through time, it's now realizing a 20 bushel per acre yield increase for corn, but also grazing the cover crops had a value of $25 per acre. So total increase in revenue is $109. Thus, the total benefits are $164.94, and the cost or the additional expenses are $40.74. And the change in net farm income is $124.20. For soybean, reduced expenses were $56.58, additional expenses $33.66. Yield increase due to planting cover crops is 6 bushels per acre. And then the total, and then add the grazing revenue, $25 per acre. Total additional revenue is $85. So the total benefits are $141.58 against a total cost $33.66. So the change in net farm income is $107.92. So in this case, yes, when cover crops were added to a no-till system, the change in net farm income was positive. So the next farm we want to look at is a different crop. It's in a different region of the country. It's partial budget analysis, and initially it's in conventional tillage, and we're looking at it as it adopted no-till and cover crops. The total farm is 6,600 acres of corn, soybean, and wheat in South Carolina. It's been practicing no-till for 10 years, planting cover crops for 7 years. And in this demonstration, we're just going to look at cotton, the 2,000 acres of cotton. So as the farm adopted no-till and cover crops, has been able to eliminate these field activities: disking, subsoiling, disking again, and then planting. And then after planting, post-plant, it was 2 applications of dicamba herbicide. The farm has been able to reduce nitrogen by 20 units and potassium by 90 pounds. And previously, before no-till and cover crops, the farmer is having to apply 1 ton of lime annually. This has been eliminated. Previously, when it was in conventional tillage, the farm mowed the cotton stalks after harvest, and that's no longer done. So the farm has added cover crops. The seed is $22 per acre, and the seed mix is winter cereal rye, hairy vetch, winter pea, crimson clover, tillage radish, and black oats. And this farmer had attached a air seeder onto a Phillips Harrow, and this is how the cover crops were planted. The seed would be dispersed, and the Phillips Harrow would incorporate the cover crop seed mix into the soil. And then afterwards, it was sprayed with Gramoxone. And then, in addition to spraying it, the farmer came and then roller crimped it. When he was using his no-till planter, he did have to increase the seeding rate of cotton by 10%. And he has added 2 applications of Enlist herbicide. So in this case, we have, for the farm with the cotton, total reduced expenses are $157.14. Additional expenses, $94.47. Farm said that there was no increase in yield to adopting no-till and cover crops, or no additional revenue. So the total benefits and the total cost, and then take the difference, and this a change in net farm income of $62.67. The next farm we want to look at was out west in Oregon. So the partial budget analysis is conventional till as the initial practice, and then adopting no-till and cover crops. The farm is 2,400 acres total. In each year, 1,200 are fallow, and the other 1,200 are planted to winter wheat and sunflower. It's been practicing no-till for 15 years and planting cover crops for 5 years. This is a relatively dry area in Oregon with 12 inches of annual rainfall and 13 inches of annual snowfall. So as the farmer has planted annually 1,000 acres of wheat, the field activities that are now eliminated by adopting no-till are disc, chisel plow, and also the farm has eliminated application 45 units of nitrogen as anhydrous ammonia. Previously, the farm was having to use a rod weeder 4 times across the field. And then after that, the wheat was drilled in September. Now the farm plants cover crops for $25 per acre. The seed mix is triticale, oats, common vetch, spring peas, Ford collards. And the cover crop is planted with a no-till drill in April. And then he comes in with a no-till drill after that and plants the winter wheat. And instead of 45 units of nitrogen with anhydrous ammonia, it's now applied as 45 units of dried urea. And then he has had to add an aerial application of fungicide. For sunflower, the field activities that are eliminated adopting no-till are disc, chisel plow, and then no longer has to spray residual herbicides. Then he has eliminated field trip with a harrow, and then sunflower are planted with a drill. Now, after adopting no-till, this farm didn't plant cover crops before sunflower. He has added pre-plant herbicides and then plants sunflower with a no-till drill. So the partial budget analysis for this farm are reduced expenses of $72.35, but then additional expenses are $94.04. This is the first example we've had when additional expenses are greater than reduced expenses. However, by adopting these practices, the farm has increased its wheat yield by 20 bushels per acre, so revenue has increased $110 per acre. So the total benefits are $182.35 against the additional cost, which are the additional expenses, which are the cost. So the change in net farm income is $88.31. For sunflower, reduced expenses are $54.91. Additional expenses are $38.56. No change in yield. So in this case, reduced expenses are greater than additional expenses. And so therefore the change in net farm income, by taking the difference in the benefits and the cost, is $16.35. And then the final farm that we want to look at is a walnut orchard in California, 193 acres of walnuts, initially in conventional production, and has adopted a soil health management system. And this has included cover crops, and the farm's been doing this for 6 years. So by adopting cover crops, the farm has been able to eliminate 5 miticide applications, 1 spray for codling moth, 1 spray of a fungicide, but also has eliminated 120 units of nitrogen applied with fertigation. And this eliminates all applied fertilizer. Also, with water conservation, the farm has reduced 8 inches of irrigation water. Previously, it was applying 32 inches, so the reduction of 8 inches is now applying 24 inches. The cover crop seed mix is $25 per acre and includes annual rye, oats, wheat, barley, triticale, chicory, mustard, radish, velvet peas, vetch, and phacelia. The farm plants cover crops in November after walnut harvest was in October. He plants the cover crops with a drill and a planter, 2 different field trip applications in crossing patterns. Then after the cover crops grow, he comes and roller crimps the cover crops in April, and then he shreds the cover crop residue with a flail mower. He custom applies compost instead of fertilizer. The application rate, application charge is $40 per acre, and the compost value was $160 per acre. So if we take a look at the partial budget results for this farm, we see that the reduced expenses are $695.92. Additional expenses, $270.73. No change in yield. So the total benefits minus the total cost result in a change of net farm income of $425.19 increase. So as a summary, we see that U.S. farmers could increase their net farm income by adopting the soil health management systems that we've looked at, or reducing tillage and planting cover crops. The total benefits are greater than additional benefits incurred due to planting cover crops. The question is, how many years does this take? In the data that we collected, we have the initial inputs with conventional, and then we have what the farm is doing right now with the results due to adopting the soil health management system. We don't have stages of transition. This is an area that we're looking into, and we want to explore this more. And finally, the adoption efforts should focus on increasing cover crop acreage, and reduced tillage will simultaneously follow. Remember, right now, we only have 5% of planted acres of cover crops. So If there's a focus on increasing cover crop acreage, it's just natural that reduced tillage will simultaneously follow the planting of cover crops. I'd like to thank our sponsor for this presentation, the Walton Family Foundation. If you have any questions or comments, I can be reached at this email address. And for more information, you can visit our website at the Soil Health Institute.